All right, let's think about our water example. I think that's pretty good. So Acme Auto uses a random amount of water each day to wash cars. Let's denote this random amount of water that they use each day by W. Okay. Now, suppose that we know that sometimes they don't wash any of their cars. They can skip a day or so, or if the conditions are right or something. So let's say 25% of the time they don't use any water. Okay, that's what that says. Otherwise, conditioned that the company uses water, let's say that the density function describing the amount used, and that's W, is, let's say it looks like this. From 0 up to, say, 1,000 gallons. Okay, so they can't use more than 1,000 gallons for some reason. I don't know how high this is going to go. We'll just call it C. And I'll make this go up to C. See? Like this, I guess. Okay. So this is not a real density function. Let's see, how do I want to write this? I could say that maybe this is the density function that for W given, this is okay, given that W is actually greater than 0. Okay, so if I tell you, in fact, that we're washing cars today, then we're going to use some water, and then we'll have a proper density function. Okay, so this is a condition, what we'll call a conditional density function. Just condition that we're actually using water. What has this got to be? What does this C mark got to be? This is a straight line here, by the way. Okay, this density function is 0 down here, and it's 0 down there. So I guess this has to be, what, 2 over a million times X? Or times W, I guess. Yeah, because see, so if this is an actual density function, I need it to integrate to 1, right? So 1,000 times 1,000 times this much times a half should be 1, right? So yeah, I think this should be 2 over 1,000. C is 2 over 1,000, right? It's 2 over 1,000 times 1,000 is 2. Take half of that because this is a triangle. Okay. Now this guy has to be the slope, right? Slope. This is the slope, which is the rise over the run, which is this. This is the rise over the run, which is 1,000. So okay. So I think that's right. Should probably multiply by an indicator function that W is between 0 and 1,000. Okay. Technically, make it half open. Okay. Now, but remember, it's important that we keep in mind that this is conditional. This is conditional. That is, this is conditional on W being greater than 0. That is, the probability that W is, say, less than or equal to, say, 500 gallons, given W is greater than 0, is, well, this is going to be the integral from 0 to 500 of, I'm going to integrate that density function, right? 2 over 1,000,000. That's just a stray mark there for free. Here, there's another one, and then another. Okay, it's 2 over 1,000,000. Oops. And then times W, I guess, and then dW. Okay, so if I carry that out, I get a quarter. So, but that's a conditional probability, right? That's a conditional probability. So that kind of lines up with what we have over here, right? If you take a look, if I make the market 500 here, what I just found was the area of this. This is a quarter, okay? Which makes sense, right? Because here's another area of a quarter, and here are 2 more areas of a quarter. They all come together to make one big dollar.